So in this session, we're going to cover strings, we're going to cover arrays, functions, and references in Rust. But like I said, there's something we never covered yesterday, so you're going to begin from that point. Okay. I hope you're able to see that, guys. Now, maybe just to take us through what we went through yesterday, we talked about variables. What are variables? How do we declare them in Rust? How do we manipulate them? Okay, so all that was covered yesterday. We also did types. We covered types. So basically, what data types are available to you as a developer while you're using Rust to do your program. Then we covered some control structures. In this case, the conditional logic or the conditional flow. And we talked about the if statements, the if-else statements, the if-else-if statements, and also the match statement. So the match is what we said is if you're coming from JavaScript background, that is, it is what you have in JavaScript as a switch statement. Okay, so in Rust, we have it as a match statement, and that is basically how it is done. So now we're going to conclude day one's work by covering loops. Now, one of the control structures we mentioned yesterday was iterative logic or repetitive logic. And these are logics that repetitively execute a block of code until a condition is met. Now, these are what we're referring to as loops. Okay, so it's a loop is basically a way to specify flow of control in a program. So that is the control structure definition. A loop, the statement I've just highlighted, is a programming iterative logic. Okay, one of the control structures that executes a block of code until a condition is met. So that is basically the definition of a loop. Now, in Rust, we have three types of loops. The first loop is what we refer to as the infinite loop. And the second type of loop is what we refer to as the while loop. I know, guys, if you're coming from JavaScript or any programming language, you should be very familiar with this. And you also have the for loop. Yeah, of course, you're also familiar with the for loop, but I think the syntax is a bit different in Rust. So let's begin with the infinite loop. Sorry. Let's look at infinite loops. So how do we declare an infinite loop? So there's a keyword that has been availed to us called loop. So if you wanted to execute a block of code infinitely, by infinite we mean there's never going to be a point in time in your program that this loop is not going to execute. So it will execute forever as long as the computer your program is running on is alive. Okay, so that is basically what it means. So let's say we wanted to print some text here. So let me have some control, because I can't execute it as it is infinitely in my machine. It may, cause some, it may crash my machine. So in order for me to avoid that, I'll just allow it to execute for some period of time. Then after that, I break out of it. Now, whatever is going to help me bring in that control is a variable we're going to create here, and I'm going to call it counter. So I'm going to initialize this and give it the value 0. Then inside the loop, I'll basically print that value. So I'll simply say counter, then I specify the value of our counter. So in this case, it's going to be counter. Okay. Then down here, I'm going to check. So I'm going to have an if statement. So I'm going to check if the value in my variable counter is greater than 10. Okay, if that is the case, then I'm simply going to break out of the loop. So this means that I'm only going to allow this loop to execute 10 times the print line statement. After that, I'll simply break out of the loop. However, with the, my counter has the value 0. So for me to even get to 10, I'll have to increment this value. So what I'll do is basically come here and do counter plus equals 1, then terminate that. Now, for me to be able to run this, guys, again, you'll just allow me make the change. So I think I took us through what is happening right here yesterday. So I'm just bringing in the file loops. So _for _loops.rs file, and I'm invoking or executing the run function within this file or this module. So as you can see, we are here. So this guy is telling me, hey, you cannot assign twice to immutable variable. Like I said yesterday, all variables are immutable by default in Rust. So if I wanted to change the value in this variable, then I'll have to use the keyword mute. So that was basically why my compiler was complaining at that point. Now we have all that in place. And now what I'm going to do is basically bring up my terminal. I hope you can be able to see that. Great. Then I'm going to run or to do cargo run, which is going to execute our program. So this is basically going to compile it down and run. So as you can see right here, it has printed the values from 0 to 11. Then after 11, it basically broke out of the loop. Okay. Now, why did it print from 0 to 11? Yes, Alison?
Yes, I have a solution. You see, let's say in the program first, the condition comes last.
Yes.
However, the actions are performed at the beginning of the program.
Great. So that was the trick. So it means if we brought these at the beginning, somewhere there, so it means our loop would check the condition first before proceeding with printing the value of that counter. So you realize if I now go ahead and run this, it should print from 0 to 10. Yeah, so God, that was excellent. So that is the reason why. So the conditional statement was coming last after we print, not first. Great. So that is basically it about the infinite loop. Thank you so much for those who participated in that, Gad and Eric. So let's move on to the while loop. Now, the while loop, we are given the keyword while, definitely, like in every other language. So we have the while keyword, but then our while keyword requires some condition or an expression that is going to control execution of its statements. So in this case, we need a condition. And I'm also going to create another variable that is going to help us control the execution of this particular loop. So I'm going to call this count, and I'm simply going to give the value 0. Okay. At that point, we're going to check, or rather, we're going to execute our loop while the value of count is less than or equal to 10. Okay. Then we end that with we give the body of our loop. So I'm just going to print the same value or give the same statements within our while loop. So we're going to print count value by passing in the value of count at that point. Great. Then we again are going to have to increment the value of our count variable. So we're going to do count plus equals 1. But again, as you can see within my VS Code, there's an error that has been raised. So it means that all variables are immutable by default. So I have to use the keyword mute for me to be able to change the value of count. And now the error goes away. Now, we're also going to try and execute this from our terminal. So this time round, we're going to have two different outputs. So one for counter and the other one for count. So basically 2 sets of outputs. I'll just do cargo run. Then you realize we have the first set for counter from 0 to 10. and the second set of count from 0 to 10. Okay, so that way we were basically able to implement what we did up here with while loops. So that is basically how we go about loops. Sorry, about the while loop in Rust. Now, the last type of loop I want us to look at is the for loop. And the for loop, I think this is the most used type of loop in Rust. And I think in every other programming language, if I'm not wrong, I stand corrected though. So in Rust, here's the syntax for a for loop. So let's say we have, so first of all, we have that keyword for. Then we're going to access each item given a range of values or an array, okay? So let's just call that item. So for item in, at this point, we're going to use a range of numbers, but we're going to see while we talk about arrays, how we can use the for loop to also access the items in an array. So for now, just allow me use a range of numbers. This range, within a range of numbers from 0, 1, 2, 3, 4 to 10, we're going to access number for each item within that range. Then what we're basically going to do is print the value of that item in our console. Okay, so what am I doing? So we're going to do, so let me call this number just to make some things elaborate. Then I'm simply going to print the value of number inside there. Okay, so you realize that this is a bit simplified. So you don't have a lot of statements as was with the while loop and the loop, the infinite loop above. Right here, it is a bit precise and clean. So for the value of number in 0 to 10, in a range of 0 to 10, simply print the numbers. So we're going to execute this as well in our terminal. And this time round, begin, we're going to have 3 sets of output. One for counter for our infinite loop. The second one for count, that is our while loop. And the third one, let me just do this. Let me just give this number. So the third one is going to be number for our for loop. So let's just go ahead and have this run in our terminal. Great. So right here we have the first set counter 0 to 10, second set count 0 to 10, and the third set number 0 to 9. So why did it print from 0 to 9 and not 0 to 10? Maybe someone might ask. Let's get back to our source code. So right here, we are specifying a range. And when you specify a range, the number or the numbers within that range will be accessed right from the start of the range to a number less than the end of that range. So in this case, if we wanted to print from 0 to 10, then it means we would give a range of 0 to 11 because the last digit of the range or the last number within that range is not going to be printed. So if we wanted to print from 0 to 10, we would give a range of 0 to 11. If we wanted to print from 0 to 9, then we would give a range of 0 to 10. So that is basically what happened right there. And yes, that is it about loops. We're done with days 1 activity. So we're moving on to day 2. And like I said here, the items we're going to cover for day 2, that is the string, the array, the function, and the references. So again, it's quite a bunch of work. So we're going to start with strings. And just before I proceed, allow me make the change. So I'm going to run the day 2 module. Apparently we've been executing day 1 module. So what I'll do right here, is I'll just bring in day 2 module and have that as well, rather execute it within my main function. So again, don't worry why we are doing this within our main function. I talked about these yesterday. So once you get the video, you're going to be able to know why all this is happening. So our day2 module should have a function by the name main. So I'm just going to make this right here. So you realize that apparently it is empty. So the very first thing I'm going to do is do a public function, give it the name main, then we're going to do perform some statements within it. So whatever we're going to do inside the main function is to execute our run function within the string module. So I'm basically going to invoke this run function inside this module file. So I need to import it. And how do I do that? I use the keyword mod to bring the file _1_string as a module within this file. Then after bringing it as a file, so after bringing it within my mod file, I simply go ahead and execute the run function in my file string. Great. So that should be able to do it. Just go ahead and close everything for now. Then great, we are here. So we're going to talk about strings. Now, when you talk about strings in Rust, first of all, if you think about string generally, it's basically a sequence of characters, right? Put together. So it could be a sequence of, letters. It could be a sequence of alphanumeric characters and all other characters you can think of. So that is what constitutes a string. Now, in Rust, we have two types of strings or data types that depict strings. The very first one is what we refer to as primitive strings. So primitive strings are immutable fixed length string somewhere within your memory. So these type of strings are stored within your bytecode. You realize that once we define them, they are going to be stored within our program, okay? The bytecode of our program. So already the value is there. We only need to do referencing to that particular value. The other type of string is what we refer to as string. So a string is basically a growable heap allocated data structure. So the value is not going to be stored within our program or the binary of our program, but it is going to be stored as a heap. Okay, so usually the primitive data types in the primary memory of your computer or any computer is stored in a stack. So basically, I hope you know what a stack is. If you have coins put on your table, then you pile them up. We say they're stacked. So they're basically put on top of each other. So the primitive data type values are stored in memory in a stack. So they take that format stored in memory. But growable strings, by saying they are heap allocated data structure, it means they are thrown anywhere within your memory, but then what is stored in the stack is a reference to where they are stored within the memory. So they can be stored anywhere within your computer memory. We don't have to organize them in a stack. We don't have to organize them in whatever manner. We can just store them anywhere within the memory, then get a reference to them. And that reference is what we have in the stack. So it means these values or these such growable data types can easily stretch and contract. In this case, you can easily add elements to them and remove. Okay, so that's why that is where the difference comes in. So I'll just let's begin by defining a fixed length string. So I'm going to do a variable. I'll call it name. Then I'll just give it a value. Let me give it a value that. So you realize that there's a type hinted to me by my Rust analyzer, and it is &str. So this is how we define a fixed length string, because we already have the value in place. We're not expecting the value some later in time, okay? But we have it in place. So these values basically going to be stored in a stack within your memory during the execution of your particular program. So if I were to change this value, I'll simply need to have my name variable or make my name variable mutable using the keyword mute. Then I can easily come down here and say name. Now, at this point, I'm changing the name, the value stored in our name variable from God to something else. And I'll name this Eric. So you realize that that worked perfectly. Okay. If I were to do away with this keyword mute, then it will raise an error. Why? It will say that I'm trying to assign twice to an immutable variable. So all variables are immutable. They are unchangeable by default in Rust. So for you to be able to change them or make them mutable, you have to use the keyword mute. So that is how we go about a fixed length string. Now, fixed length strings accept their values upfront. So they basically have a fixed length of string upfront. They don't expect it to change anytime within the execution of this particular program. So if I do print, then I simply pass in the value name. Let's see what you're going to get in our terminal. So I'll just do cargo run. And that simply, oh no, okay, it's printing name, not name, but name. So in this case, we're printing the variable or the value stored in the variable name, not the string name. So I'll just redo this and we're going to get Eric. Okay, so we basically printed that out. Now, let's look at the other type of string, the growable string. So what do we mean by a growable string? And like I said, these are strings that we can add some elements to it so we can grow them. We can make a sentence with them, or we can remove some words or characters from them, okay? So they are not just a fixed length. So let me do another, let me call it sentence. So this is another variable we are declaring. But now, instead of giving it a value, as I did in line 8, I'm going to use this particular object called string. Then in that string, there's a static method called new. So that is the method we're going to use. So up to that point, we've simply declared our string. We still have nothing in it. Though we can still go ahead and put some word here, it's still allowed, okay? Okay. In that case, if you were to do that, we'd use another method, a different method called from. But let me use the new method because I want us to construct this sentence from scratch. So we have our sentence initialized. Let's go ahead and build up our sentence, right? So I want to do sentence. I want to do sentence. Then I want to push. Let me push some character to this sentence of ours. So let me just push H. You realize it is raising an error, and that is simply because we didn't make it mutable in the first place. Let me just do that. So we have a sentence containing a single character. Up to now, we only have a sentence containing a single character, and we are going to print this out and see what that is going to be in our terminal. So if I do cargo run, this is going to print H, as you can see. Okay, so just H, because that is the only character we have within our sentence. Now, I'll just do away with this. Let me just do away with that. Then, so that is basically how you would initialize your sentence or your string, guys. But There's another method I hinted, the from method. So if let's say you wanted to initialize your string, but with some part of your string or part of your sentence, you wanted to initialize it with it, you'd use the method from, then basically give the word or sentence you want to pass in. So in this case, I'm passing in hello within our sentence. Okay. Then let me just okay, let's move on right here. So after giving it hello, our next comment says that we need to check the length of our string. Now, the word hello, in this case, our string is of length, let's say 1, 2, 3, 4, 5. So it's of length 5. It has 5 characters within it. So let's see if that is exactly what is going to be printed right here. So I'm going to create another variable. I'll call it len for length. Then I'll simply do sentence. Now there's another method that has been availed to us that we can use to check the length of a string, and that is len. If you're coming from Python, I think this should be familiar in a way. So len is basically returning a value of type usize. I know I never talked about this, but you guys are you can do more research on that. There's actually a book I'm going to share in the group. It has it talks about it, so don't worry about that. So if I now come here and try and print out the value of length, let's just go ahead and run this in our terminal. Let's see what this is going to give us. You realize it prints out 5. So 5 is basically the length of our sentence, and our sentence has a string hello and 5 characters. Now that is it how we check the length. So if we wanted to build up our string, so in this case our hello string, and assume we wanted to add a character, let's add a space. Let's add a space at this point. So let's do sentence, then push. So I'm going to use the method push, which accepts a character. And the character we are adding at this point is basically a space. Okay. So we just adding space, nothing else. Okay. So if I now if I print this in our terminal right now, you'll not be able to see the space within my terminal. Okay, it will be very difficult to identify that. So for us to be able to explicitly be able to see this, let's add or push another string to our current string. What we are actually doing at this point, guys, is we are basically building our string into the final string we need to have. So I'll again do sentence dot push, but then this time round, instead of using the method push, I'm going to use the method push underscore str, meaning I'm going to push another string to the string that we already have. So I'm going to push the word world to it. Okay. Now, if we now try and print this out, let me just have this printed right here. So we're going to print our sentence over here. It should print out in our console, hello, space, and world. Let's find out if that is the case. So I'll just do cargo run, and that is going to put, and to realize right here we have hello, space, and world. Okay, so our sentence is taking shape, or our string is taking shape. Let me just exit the terminal for us to be able to see this. So that is how we can build our string. Now, what if we wanted to check if our string is empty? Now, like I said, string is an object that is basically coming out of the box within the Rust language, and it has a bunch of methods you can actually use to perform different operations within your string or your string object. So one of these methods is the one you're going to use to check if the string is empty or not. So I'll simply come here and say, let's again check if it's empty. I'm simply coming up with another variable, and I'm naming that variable is empty. Then you're going to check if our sentence is empty. So I hope you see the method right here. The method is is empty. So that is basically what is going to help us be able to establish that. I think someone is on mute. Eric, thank you. So yeah, let's proceed. So at this point, we're going to check if the sentence is empty or not. So if it is empty, we're basically going to capture a Boolean variable in our variable is empty. So if it is empty, it will basically return true. If it is not empty, it will return false. So at this point, we definitely have some characters within our string sentence. So it's definitely not empty. So we expect the value to be printed out to be false. But then let's find out by actually running this. Great. So you realize that whatever is printed out is the value false. So that means that our string has some values or it has some characters. What if you wanted to check if our string contains some characters or some string within it? So what we refer to as substring. Okay, how can we check that? That takes me to the contains method. So right here, we basically want to do, let's do another variable. We're going to name it contains hello. Let's do contains world. Then at this point, we're basically going to check if it contains the word we're going to pass into the contains method of our sentence, of our string object sentence. So I'll simply do sentence, then contains, then I'm going to pass in the string that I'm going to check if my sentence contains that. So that is going to be world, the string world. And somewhere up here, if you're keen on my writing the word world, it begins with an uppercase W. So down here, if I try to check for the word world, but with a lowercase w, then that won't be found within my, but let's just go ahead and give this a try first before I make that change. So again, this tells you that Rust is case sensitive, right? So I'm going to check if if there's the word world with lowercase w within my sentence. So let me just print this out and see what this is going to give us. Great. So you realize it is giving us false. Why? Because it never found the word world with the lowercase w. So that's why it is giving us false. Yes, yet we have the word world within our sentence, right? So let me just use the uppercase W, which should now give us true if we execute this. Great. So as you can see in the terminal, it is now giving us the value to be true. So I'll just again exit the terminal for now. Then let's cover the last method for strings. And here we are saying that we can as well be able to replace, okay, replace a word or a character within your string. So how can we be able to do that? Now, right here, I'm going to have my sentence version 2. So version 2 of my sentence, that is how I've named that variable. And we're going to do sentence, and we're going to invoke the method replace, okay? So we're going to replace from a word to a word. So we can replace from, so let's replace the word world with the word down here. Let's replace with the word Peter. So right here, and I'll just print this out for us to be able to see the changes we've made to our string. So down here, I'm simply going to print out our version 2 of the sentence. So we went to our first sentence and we invoked the replace method. Now the replace method is basically going to take our previous sentence, make the replacement, then return to us the final version after making the changes. So that is what we are storing in our sentence version 2 variable. And that is what we are actually printing out. So let's go ahead and see what this is going to give us in our console by doing cargo run. So you realize that this time around it gives us hello Peter. Okay, so hello Peter was printed out after replacing world with the word Peter. Okay, so that is how you do replacements, or you can replace a word within your string, a character within your string, and all that. So yeah, that is basically it. So that is it about strings. I don't know if there's a question on that as well. Anyone with a question on that? Okay, I hope not. Great. So let's move on. So at this point, we're going to move on to arrays. Let's move on to arrays. And just before we do that, I'll just head on to my day 2 module file and import my arrays file. Sorry, bring in my arrays file. Then I'll comment out the string because you're done with that. Done with that. Then I'll just invoke the run function of my arrays file that way. So that is a simple change we needed to make. Then I'll simply head on to my arrays. Now, when we talk about arrays, what is an array? What is an array? I think there's some hint within my screen. I don't know if there's anyone who can see it. Let me ambush someone. Lawrence, are you there?
Yes, I'm here.
Yes, maybe you can just tell us what an array is.
An array is just a list of items of the same data type.
Yeah. So an array, just like we declare variables in our program, right? So we are basically declaring a single variable to hold a single type of value. Okay. An array is a list of such items. So we could, let's say we had a variable name storing a string. We have a variable country storing a string. We have a variable village storing a string. An array would simply combine all these because they are all of the same data type. So it would store them all together under one variable name. Okay. So it is basically a fixed list where elements are of the same data type. Now, something to note with arrays in Rust, we have the primitive arrays, one that I'm going to take us through now. Then we have growable arrays. Just like strings, we have fixed length string and growable string. So right here, we also have fixed length arrays, but we still have a growable array or growable length arrays. Now, the one that I'm going to talk about the first is the fixed length array. And let's call these numbers. And these are basically, this is how you would basically declare a fixed length array. Now we're going to give this a data type because there's something critical I want to mention right here. To give it a data type, you do the semicolon as usual with other data types. Then we use the, are those square brackets or what? Yeah. So inside those brackets, we're going to give the first item within the bracket is the type of element that are going to be stored within your array. So at this point, we have integers, and in this case, positive integers within our array. So we're going to specify that, hey, our array is only going to store 32-bit of unsigned integer. Okay. Then we separate the type of element using a semicolon. Then after the semicolon, we specify the length of our array. So at this point, you're going to expect, say, 7 elements within our array. Okay. 1, 2, 3, 4, 5, 6, 7. So our array is apparently has 7 elements in it. So that's why you can't see any array. However, if I went ahead and removed an element, you should raise an error. Great. So you realize there's a red squiggle line underlining the array list, and it is saying that, hey, there's a mismatch type. It expected an array with a fixed size of 7, but then it found, I think those were 7 elements, right? So it means if you're going to give less than what you specified, so elements of a size less than what you specified, then an error is going to be raised. If you provide something more than what you've specified, an error is still going to be raised. So you have to give the exact number of elements you've specified right here within the definition of the data type or the type. So I really hope that is home. So that is basically how we do, we declare an array in Rust. So what if we wanted to get, print some values within our array, or in this case, the array elements? How do we go about that? Let's do a variable. Let's call this variable number. And in this case, we're basically going to access a number, right, from our numbers array. So I'm going to do numbers, then provide the index where the element I want to access is located. So for instance, we say we wanted to access the value 3. This would be at index 1. Why? Because the first index, or the index, array index, begins at 0. So my value 3 is at index 1. So that is exactly what I'm going to pass inside there, then terminate that statement. And right up front, my analyzer suggests a U32 data type. So I'll just explicitly give that as well. Then from there, let's go ahead and print this out in our console and see what is going to be printed out to us. So I'll just pass that in. I've passed the number variable in this case. So like that. Then I'm simply going to do cargo run from my terminal. Let's see what is going to be printed out. So you realize it prints out the value 3. So that is basically how we go about that, accessing values. Now you can use an array again, guys, don't forget, you can use an array to do that work. I'll be showing you as we proceed how we can be able to do that. Now, let's say we wanted to reassign. In this case, we're going to change the value in a particular index within our array. How do we go about that? This is how we do it. I'll just copy this down here. So we're not going to declare any variable, but we're going to access within our numbers array. We're going to access a certain index. So let's access index 1. Apparently, index 1 contains the value 3, but then we're going to change that. And let's change this to something else. So let's give it the value 47. Okay. Now, at this point, we are trying to change a value within our array. But by default, variables are immutable. So how do we go about this? I need to make the numbers array mutable by using the keyword mute. And always remember, the keyword mute in your variable declaration comes after the keyword let. Okay, so really take good note of that. So after giving that, you realize the error has just gone away over there. So at this point, I'm changing the value at index 1 from 3 to 47. Now, if I try to print out my array at this point, let us just try and print out the whole array. Okay, the whole array. There's an error that is raised, and I think I talked about this error in our previous class. I'm trying to print an array, but then the array data type or the array object doesn't implement the display trait. So there's a way we said we can go about this. What I've just, so that is how we can basically implement that. So this is basically going to print out all the elements within our array in our terminal. So let me just clear my terminal and run this. Let's see what is going to be printed out. Awesome. So you realize it prints out a list, but then this time round, we don't have 3 within our list. So usually, or at first, we had 2, 3, 4, 5, 6, 7, 8, 9. But then in our terminal, after making the change at index 1, we have 2, 47, 4, 5, 6, 7, 89. Okay, so that is how we go about that. That is how we reassign a value in an array. What if we wanted to get the length of an array? How can we go about that? So I'll just give this variable name length. Then I'll use my numbers array. Then I'll simply invoke the len method of that object. So the len method is going to return a value of type usize, which is going to indicate the length of our array. In this case, the total number of elements or items within our array. So let's see what this gives us. So it definitely should give us what we specified up here, 7, okay? Because we've not added anything to it, we've not removed any element from it. But let's confirm this in our terminal by doing cargo run for us to be able to establish that it indeed prints out 7. So I hope you can see that from the terminal, okay? And I really hope I'm not going too fast, guys. If you have any question, just feel free to raise it up. So that printed out 7. Just exit the terminal for now. Great. The last topic or subtopic or item I wanted to cover within the fixed length array is the slice. So slice is basically, you have an array, your array could be having thousands or tens of thousands of items within it. But then you just want to get a portion of it. You want to retrieve a portion of it. How can you go about that? So like in our case, our array has 7 elements, but then let's say we just wanted the first 3 elements from the array. How can we go about that? So at this point, I'll just do another variable. I'll call it, let me call these sub numbers. Okay, sub numbers. Then our sub number is going to get a portion of numbers. So from a certain index to another index, it is going to it's going to get the values within that range of index. So I'll just do numbers, then I'll use the square bracket. Then right here, I'm going to bring in the range. If you can remember the range syntax I used while covering the for loop. That is exactly what I'm going to use here. So we're going to access numbers from index 0 all the way to index 4. Okay, then I'll just terminate that statement. Now, my variable has an error. Let's see what the error is saying. The size for values of type that cannot be known at compile time. The trait size is not implemented for this. So how exactly do we go about this? So at this point, we are trying to access the items, all the numbers in the array numbers, and directly allocate them to this variable. Okay. There's a concept in Rust we refer to as ownership. I'll be covering it as we proceed. But for now, this statement is invalid because we are trying to get ownership of elements that are within a different or another variable, which is not allowed in Rust. So for me to be able to go about this, I only need to specify that, hey, instead of taking ownership of these values, let me just get their references. Okay. So by adding that ampersand before numbers, before our variable name numbers, we are simply saying that, hey, instead of getting the actual values, just give us references to those values. Then we'll be good to go. So that's why you see the errors gone away. Now, if I try to print this out, let us just print our slice out and see what is going to be displayed in our terminal. So I'll just print that out. Cargo run. This one is going to print from index 0, so 2. So 0, 1, 2, 3. Okay. And again, if you can remember what I said about ranges while we were covering loop, is that it will execute right from the first value of your range to a value do I say a value below or a value -1 of what you've specified in your range. So if you're specifying from index 0 to 4, it means it's going to print values from index 0 to 3. Okay. So that's why you have all these within, you have another array in our terminal, but then this array doesn't contain all the elements that we specified up here. So it has all the values up to 5, but then the rest are not available. Why? Because it created a slice out of it. So another sub array of numbers out of our original array. So that is basically what is happening at that point. Just exit out of that. So that is it about our fixed length arrays. So at this point, there's also another data type we covered yesterday, and it's called the tuples data type. Tuples are basically, I'd call them, they are like arrays. It's only that they have something different from the usual arrays we know about. And again, if you're coming from Python, I think you're familiar with this. Tuples group together values of different types. Okay, so unlike in our array where the data type of elements must be the same, or our elements must be of the same data type, a tuple can contain different or values of different data type. Okay, and in Rust, the maximum elements that can be contained within a tuple at any given point in time is 12. So if you wanted to have a tuple with 13 elements, that would bring in some error within your program. The maximum you've been given is 12. So how can we define a tuple in Rust? Let's just see how we can go about that. So let me do profile. Let's call our tuple profile. Then we give it some values first of all. So let's say we wanted the name. So we can give this name. Then we have the age. So we're basically building up a profile. So name, age, and town. So town could be, what town, guys? Let's give it a town. Let's give it a town. I hope that is a town, if I'm not wrong. Great. So we are having a tuple of values right here, Fleming 67 Malindi. But then our tuple requires a data type. Like we have to give it a data type. Okay. My Rust analyzer has hinted that for us already. So it is kind of helping me, guys. So don't be confused with that. So I'll just explicitly provide this. So I'll give Fleming is a fixed length string. So we'll just give it that data type. 67 is an unsigned 32-bit integer. So I'll just give it that. And Malindi is also another fixed length string. And yes, that is how we declare or define a tuple in Rust. So you have the variable name, the type looks like that, and the value is represented like that. Okay. So if I were to access a value within this tuple, then I would simply come down here and say, first of all, we can print the whole tuple using the keyword or this literal I have up here. If I do print line, then use colon question mark, I should be able to print this tuple as it is in my terminal. Okay, so I'll just go ahead and do that. Now, for me to be able to, you realize that this is a function. I'll be talking about functions in a bit, but this is a function. So for me to be able to invoke this function or to be able to run it, then I'll need to bring it within our run function, which is what we're executing in our module file. So that is basically how I invoke it inside there. Then I'll proceed with my program down here. So at this point, I'm going to print out our tuple as it is. So let's see what this is going to display. Awesome. So you realize it displays to us the tuple as it is. So bracket, Fleming, 67, Malindi, and closing bracket. Great. So let's see what if we wanted to access a single value or a particular value in our tuple? How can we go about that? So let's say we wanted the name. We'd simply come here and say, now let me just give this as a print statement. Or, okay, let's store it here. We do profile dot. Now, our profile, maybe if I get there, our profile has 3 items. So if I wanted to access the first item, I would do dot 0. That means dot index 0. If I wanted to access the second element, I would do yeah, I hope that is now visible. The pop-ups were kind of obstructing that. So in this case, I'm accessing the first value within my tuple, which is a name. If I wanted to access the second item, I would simply do dot 1. So dot index 1, that will give me 67 in this case, which is of type U32. If I wanted to access the last item, in this case, the third item within my tuple, then I'll just need to do dot 2. Okay. And I hope you can see how the data type is changing. So we just wanted the name. So I'll just do dot 0. Then I'm going to print. We're now going to print that out. Going to print the name out. So these should print only the name. Okay. These should print the name to our terminal. So let's go ahead and see how this is going to turn out. Great. So you realize that it is printing the name Fleming in our terminal. Why? Because that is basically what we accessed in line 33. So that is basically how you can do that, access the elements within a tuple. But what if you wanted to change an element within a tuple? Would it be possible in the first place? So let's come here again. Before we can mutate a variable, we need to use the keyword mute. Then down here, I want us to try and do profile 0. So somewhere down here, I want us to do profile 0 is equal to something else. So let's do beta. Then after that, try and print out, let's try and print out our tuple as it is. So the whole tuple profile. Let's see what this is going to give us. So I'll just comment this out and say reassign value. Okay. So at this point, we are trying to change a value within our tuple. Let's execute this and see if it is possible. Great. So we just changed the value. We just changed the value from Peter sorry, from Fleming to Peter. Okay, so we did Peter 67 Malindi. So that that was executed successfully. That executed successfully. What if I try to do profile and just try and change everything altogether within that particular tuple? So let's say I wanted Peter here, give it some other value, and give it that. Then down here, I want to try and print this out as well. Let's see if this is going, how this is going to run. And great, we're also able to do that. So we're able to change all the values within a tuple. So in this case, reassigning the whole tuple altogether. Now, if, however, in our same tuple, if we tried to interchange these values, so let's say it expects the second item to be a 32 integer, a 32-bit unsigned integer, but then you came here and put a string, okay? That is going to raise an error because it is going to get this value, try to interpret its, run this through and give it a data type. And these are definitely a string. So a string is not a U32 data type, you just specify in its definition up here. And so that is why this error is going to come in, okay? So I really hope that is clear. And yes, that is basically it about tuples. That is basically it about tuples. It can contain different data types. It has a maximum of 12 elements. And we can't interchange the values given the data type that is we specified. So is there any question up to that point? Any question up to that point? Okay, no one has a question. So let's proceed, guys. Now, I'm going to move on to the third item, and this is what we refer to as growable arrays. So these are arrays that can either expand or contract. They are resizable, okay? And they are stored in heap. These are heap data structures, so they are not stacked, or they don't have a fixed memory size. They can, you know, expand and contract as they want. That's why we refer to them as growable arrays. And they just work exactly as arrays do, okay? So there's really no difference between these vectors. We refer to them as vectors in Rust. These growable arrays, we refer to them as vectors. So there's really no much difference between a vector and the normal array. The only main difference is that the vectors can grow and contract, but arrays cannot. So I'll just use our array up here, this array of numbers, but we're going to have a different representation of the same in vectors. So let me do let vectors, sorry, let numbers. So this is going to be the name of a variable. Then be keen on how we're going to initialize this. So instead of going ahead and saying, doing it as a normal array, so 2, 3, 5, 7, 89, and all that, there's something, or there's a keyword that is coming just before that, and that is the vec macro, okay? So we are having this vec keyword and an exclamation mark. So anything that has a name then followed by an exclamation mark, usually it is referred to as macro in Rust. So most of the time you'll hear it being referenced as a macro. So we're going to have this. Then this is basically how we represent that. Then its data type is going to be a vector, so vec, and our vec is going to have elements of the same data type, and in this case, the data type is going to be unsigned integer of 32-bit. So that is how we declare a vector in Rust. So this is a growable array. How can we get a value of this particular vector? We simply need to come here. So let's say we wanted a number from our numbers vector. I'll simply come here and say, hey, numbers. So my numbers vector, I want you to give me a number at position, sorry, at index 2. So at index 2, we have 0, 1, 2, we have the value 5. So we expect the value 5 to be stored where? Right inside here. This is going to be of type that again, okay? So this is going to access the value in our numbers vector and basically put that value inside here, okay? So if I go ahead and print this, let's just see what is going to be printed in our terminal. So I'll just pass in here number. That is how we do the printing. Then again, guys, this is a function and we've not yet invoked it anywhere. So if we try to run our program as it is, nothing will be, we will not get the result we wanted to see. So I'll just go ahead and invoke it within our run function over there. Then I'll comment out the tuples function. Now, while you're going through this file, you can uncomment it and see how things are folding up. But for now, let's deal with vectors. So that is exactly what I've done right there. And I'm going to now run this in our terminal. Let's see how this is going to build up. So great, we have 5 displayed in our terminal. And this is the value we expected to see based on our statement right here. So if we tried to get the value 7, we should be able to see, oh no. So 7 was an index out of bound of our vector. And that's why our program panicked. Now, by panicking, we mean there was an exception, okay? I think I love the word, the term panicking, a program panicking. So if you give an index that is out of bound, you'll get this warning or this error message, index out of bound. So if I wanted to access the 89 value, then I'll simply need to provide the right index. That should be 6, right? 0, 1, 2, 3, 4. Oh, it's 4. Sorry guys for that. It's at index 4. Yes, and now we have our 89 printed out. Great. So that is how we go about that. What if we wanted to reassign a value? Okay, so in this case, we want to, okay, we have our vector in place, but then we want to change a value. We don't just want to go with it as it is. We still can do that just the way we captured it in a fixed length array. So let's say we want to change the value at index 2, and we want to give it a different value this time around, say 400, right? So let's just go ahead and print these out as well. So there's again an error. I'm trying to mutate a value within my vector, but then I've not explicitly defined that out. I've not explicitly specified that my numbers vector is actually mutable. So that is what I just did up here by adding the keyword mute, and now the error has gone away. So if I try to print out the whole array, sorry, the whole vector as it is, it should print out, so we have 0, 1, 2. So at index 2, sorry, at index 2, we apparently have the value 5. Now, after the change, it should replace the value 5 with 400. And so we should have 2, 3, 400, 7, 89. Let's see if that is the case, guys. From our terminal, by doing cargo run. Great. So you realize we now have 2, 3, 400, 7, and 89. So it went ahead and made the change. Great. So how about Now that we say that our vector is growable, it means it can expand, it can contract. How exactly can we add an element to our vector? Let's cover that next. So I'll head on to line 60. I'll do numbers, then push. So at this point, I want to push a value. I want to add an element to our vector. I'm going to add 567. So I've just added the value 567 to my vector. Now, this time round, if I try to print my vector in my terminal, let's go ahead and do that after pushing this integer in. Let's just do cargo run. So you realize that our array, or sorry, our vector ended at 89, but now we have it extended to 567. So the value 567 was basically added at the end of our vector. So it was like appended at the end of our vector. And so we now have 5 elements, 1, 2, 3, 4, 5, 6 actually. We have 6 elements within our vector. We initially had 5, but we now have 6 now. Let me just minimize that. Then let's see how we can remove an element out of our vector. Now, I've just gone ahead and added another value in line 60. So after adding 567, I've added another one, 300. So if I try to print this right there, you realize I'm going to have a vector with elements up to the item or the value 300. But in line 64, I'm going to remove the last value. And how do I go about that? I'll do numbers.pop. And pop is basically going to remove the last item or the last element within my vector. Now, if I try to print my vector again in line 65, we now should have a vector with the last element being 567. Let's see if that is actually the case from our terminal. So let's do cargo run. And voila, we have the first vector printed out with 300. So that is line 61. It has 300, but then in line 64, we popped out, or we removed the last item. So we removed the value 300 from our vector, and now we have a vector with elements up to the value 567. Okay, guys, I really hope that is now home. Let's move on to the next item. How can we check the length of our vector? So at this point, we basically want to capture the actual length of our vector. Like I said, it can expand and contract. So this method will basically give you the length of your vector based on the elements it has by the time you're executing this. So let's store this inside our size variable. We're going to call numbers.len. Again, the method is the same. Then after doing that, I'll basically print out the size. So let me just print size right there. Great. So these should give us the size or the total number of items or elements within our vector. Let's find out what that is going to be. So if I do cargo run, you realize it prints out 6 in my terminal. So this is the size. Maybe if I can just format it well so that we have these shown well. Oh, sorry, where did I add that now? It should be here, size. Now, if I try to just give that a trial again, now you have size 6. So it means you have 6 items within our vector, and we can count them 1, 2, 3, 4, 5, 6. Great. So again, that is it about getting the length. Now, how can we get a slice? Again, I've covered slice when we're talking about the fixed length array. So a slice is basically a portion of your array. How can we be able to do that? So again, I'll just give a variable right here, say vec subvec. Let me just call it subvec. Okay. Then subvec is going to access a portion of values within the numbers vector. So numbers. We're going to access this time round. Let's access the last items. Okay. So we're going to access items from the last item or the last index up to index 3. So you realize that the syntax is a bit strange at this point. We are having 3 followed by 2 dots. Okay, so that means this basically means it is within your vector. It is going to access elements from index 3 all the way to the end of that particular vector. Okay, that is what that is trying to say. And again, like I said, we need to reference the values. We don't want to take ownership of these values. So I use an ampersand just before the numbers and the error is gone. Now, if I try to print these out, okay, let me just bring these over. So if I try to print my sub vector right here, I should be able to get the values I've just captured in the slice. So let me get rid of these and use the literal, then bring it out there, then that should work. Now, let's go ahead and run this in our terminal. Again, that is a statement we are trying to run. So I'll do cargo run. And great. Now you realize that our vector was initially 2, 3, 400, 789, 567. So those were the elements it contained. Now, after slicing, sorry guys, after slicing it, we have the values from index 3. So 0, 1, 2, 3, index 3 is 7. So it begins from 7 all the way to the end. So that's why we have 789 and 567 listed at that point. Okay, so that is a slice out of what we had. So that is basically how we go about that. And like I said, we need, I promised you guys to show you how we can access each of these elements using a for loop, right? And we've already covered loop, so this is going to be a breeze. Again, I said using a for loop. So for a number, and I guess we have a variable called number in our program, so that may conflict. Let me just call this item. So for item in our vector numbers, for every item in our vector numbers, we are simply going to print out the item. So we're going to do item, then we pass in what? The actual item value right there. Okay, you realize that it's very clean and precise. Now I'm going to just comment out these other print statements so that we don't have our terminal cluttered. That is just what I have done there. So we just want to see what values are going to be printed within our loop. So this should print all the elements within our vector. Let's see how these appears in our terminal. So I'll just do cargo run to run our program, and voila, we have the first item printed out, second all the way to the last. So 2, 3, 400, 789, 567, all printed out. Okay, so that is how you can bring the two concepts together, the loop concepts and the array concepts, and you realize that you already have your program building up. Great. We've covered everything we ought to cover in the array And I really hope every point is home. And again, guys, I'm going to push this to a GitHub repository, so don't worry if you're not getting some things right now. All this is going to make some sense as we proceed. So that is all about arrays. I can see a question. Let me just have a look at this first. So what if you want to remove the first value? How can you go about that? Okay. So let's see, Peter. I'll just come back to my vector function. Then we have, where are we doing the pops? Oh, right here. So at this point, like that is line 64, we removed the last item in our array. Now let's try and remove the first item from that vector, okay? I'll just do another line, a new line right there. Then I'll do numbers, good, remove. So numbers dot remove, or using the remove functions of the vector object, you specify the index of the item you want to remove from your vector or from your array, in this case, the vector we're talking about. So in this point, at this point, we want to remove the first item in our vector. So we'll just give the index as 0. Then I'll go ahead and comment these other print statements for us to be able to vividly see what's going on right here. So we are printing out our vector 3 times. 1, and then I'll just comment these out as well, the for loop. I'll uncomment it later. So let's focus on this. We're going to try to remove the first item. And in that case, it's going to be 2. Okay. So let's see how this is going to turn out. So cargo run. Great. So we are here. So we had our initial vector as listed right there, what I've just selected. So it had all the elements. Then we did the pop to remove the last element from that vector, and it removed 300. So we were left with that. Then after doing the remove, passing in index 0, it went ahead and removed 2. And now we are left with 3, 400, 789, and 567 in our vector. So I really hope that answers your question, Peter. Yes, so I hope that answered it quite well. I'll just exit that. Then make these changes, comment out what should be commented out. Then I'll comment that. So I'll leave it at that point. Great. Awesome. Yes, so that is basically it about arrays. I want us to move on to the next item. Again, unfortunately, we won't cover reference because as I can see time, it's really moving up. So let's cover functions, guys. Then we'll proceed, or we'll catch up from the reference. And I'll really try tomorrow, that is day 3, so that we really brush through these concepts as fast as possible. And we finish up everything this week with Rust. Okay, so come next week, we need to get into the blockchain concepts and now start talking smart contracts as we proceed. Okay. Now let's talk about functions. I'll just go ahead and bring in this file within my module as well. So _3 to bring in functions, comment out that, then okay, copy this, comment that out, then basically execute the run function within my function, within my functions file. Seems my functions file is empty or something. Okay, there's a very small error right here that I'm basically going to deal with as we proceed. So that went away. Great. So we have all that set up. Now let's move on to our function. Now, what is a function? A function is a procedure, just like Samson has put it. It's like a procedure. So you have a set of procedure to be executed. And either, there's a functionality you're achieving with that. Technically, we would say a function is a block of code, an independent block of code within your program. Okay, that is technically what we refer to as a function. Now, in Rust, all functions are private by default. So they are private to either your module, they are private to either your module or your structure or your file. Okay, by default they are private, and that's why if you're very keen with my run function that I've been using so far inside here, its declaration is preceded with the keyword pub. So the keyword pub for public basically exposes my run function to other modules within my project. Okay, so that's why I'm able to come here and call it within the main function of my mod.rs file. Now, if I go ahead, for instance, and just, remove it, then come back to my mod.rs, you realize that there's now, my compiler is complaining that, hey, the function run is private. So it's basically trying to infer that, yes, there's a function within the file you're trying to, you've specified. So in this case, _3_functions, but then that function is private. So we can't invoke it within this scope. So for me to be able to do away with that error, I simply come and add the keyword pub for public to make it public to the other files. Now, take note of that, and then add to the variables concept. All variables are immutable by default. All functions are private by default. We'll take good note of that. Now we're going to see how we can, invoke a function. So first of all, how can we declare a function? Then how can we invoke a function? Then how do we go about functions that need to capture parameters or arguments? Then how can we get a returned value from a function? Now, this should really be easy. So I'll just uncomment these part down here because these are going to start from. And I'm going to have a function. Now this function is going to be private within this file, and I'm going to call this function greet. Now this function is not going to accept any parameter, so it's just going to have an empty bracket. Then its body. Now within the body, we are simply going to print hello. Let's do something like doing something. Okay. So within the function body, doing something. Okay. So in this case, within our greet function, we are basically printing doing something. Okay. So if I wanted to, again, someone is talking. If you please could mute Eric. Thank you. Thank you. Yeah, let's come back. So this is basically how you declare a function in Rust. Use the keyword fn, give it the function name, which can be anything you can think of, as long as it obeys the naming rules. So a function cannot be named, a function name cannot start with a number. That will bring an error. It can either start with a letter or an underscore. That is valid. But then it can contain it can contain either a letter or an underscore within its name. It's only that the number cannot come first. So yeah, those are some of the naming rules you need to have at your fingertips. Then you give the bracket. This is basically where we're going to have parameters come in. If your function is going to accept any parameter, then you give its body. We're going to see if your function is going to return some value, how you also go about that. So that is different. Now, for me to be able to invoke this function within this other function, I simply need to come here and use its name greet to invoke it. So I simply do greet, then the brackets, then terminate that statement. So if I head on to my terminal and I do cargo run, it should print to us doing something. So right here. So this is the string we had within our greet function, which was basically printing doing something. Okay. So I hope that is clear. Let's move on to, so that is about declaring a function and invoking a function. What if you wanted to have a function that accepts some arguments or parameters? Then we do something with those parameters within our function body. And how do we go about that? So I'll just get down here again and do another function. This time around, I'm going to call it something else. What should I name this? Let me name this. Let me name this greeting, and just change this to. Let me change this name to hey. Okay. I've just changed the one we declared before to from greet to hey, and I invoked it up there. Then this other one you're going to do is going to be greeting. Now our greeting is going to accept a value or a parameter. The parameter it is going to accept is going to be a name parameter. So you're basically going to pass in your name. This name is going to be a reference to a string. Okay, a reference to a string. And we're basically going to, within our function body, now you can have a block of statements, many other statements within your body. Usually recommended is 10 lines of code within your function body. But then in our case, we're only going to have one. So we're simply going to print hello, then we pass in the name value right there. So it is going to be hello somebody, hello name. Okay. So let's go ahead in our run function and try to invoke this particular function. So under passing functions with arguments, I'm going to create a variable right here. I'm going to give these, let me give this the variable name student. Then this student is going to take the name Destiny. And so that is going to be the name of our student. Then after that, we're going to invoke our greeting function. So this function is basically going to greet the student. So we're going to pass down these, let's be explicit. So this is student name. So we're basically going to pass down this value to our function. Okay. So we do, oh God, what did I do? So we basically use the student name inside there. Okay. So by passing this, we should get, of course, the hey function is going to be executed. Then we're going to execute the greeting function, which should print hello Destiny. Let's just find out if that is the case from our terminal by doing cargo run. Awesome. So right here, you realize we have the first statement, which was printed from our hey function. Then the last statement printed was hello Destiny. So the value Destiny was basically passed down to our greeting function using the name parameter that we defined right here. So again, that is how we go about that, guys. And I really hope that is clear. Now let's cover what if we had another function that is basically going to return some value. Okay, so the two functions we've covered so far are not returning anything, so they don't return any value. So how do we go about a function if we wanted it to return a value? So let's say we have a function here called sum, and our function sum is basically going to accept two numbers, so two integer numbers. Let's say num1 and num2. So num1 is going to be of data type i32. Num2 is also going to be of data type i32. So in this case, 32-bit unsigned integer. At this point, since our function is going to return some value, we need to explicitly give the data type of the value that is going to be returned. And how do we do that? We use this arrow symbol. If you're coming from JavaScript ES6, again, you should be familiar with something like this. Then we specify the data type of that return value. So we're going to expect the return value to be of type i32. So we simply give i32 right there. Then we now bring in our function body. Now, at this point, let's have the variable result. The variable result is going to hold the summation of number 1 plus number 2. Okay, so this expression is basically going to store the resultant value in our result variable. Now, you realize that we've terminated this statement. Now, for us to return this value, we simply need to provide result variable without terminating it. So really take key note on this. If your function is going to return some value, the value that is returned should not be terminated. So right here, we've captured our value result after this expression. So whatever value that is here, for us to be able to specify that we are actually returning it, we write the name of this variable in line as it appears in line 31, but then we don't terminate it. So if I went ahead and terminated it using the semicolon, you realize that an error is raised right here. And by that, our compiler expected this function to return some data, but then as it stands, we've still not returned anything. So for us to specify that we are actually returning the result, then we do away with what? The termination. So I really hope that is home, guys. Now, coming back to our run function, let's go ahead and invoke this within our run function. So I'm simply going to have, to create a variable. I'm going to call it res. So this is a variable that is going to hold the value that our function sum is going to return. In this case, we're going to add 56 and 4673. So the summation of this value is going to be stored in our res variable, and we can definitely print that out. So we do a print and we say sum. Sorry. We're going to format our string. So we say sum is, and we pass in our variable res right there to indicate the value that was returned by our method. So if I go ahead and execute this in my terminal, we get the sum with the value 4729. So if you add 4673 plus 56, you get this value 4729, and that is exactly what was printed out in our terminal. Okay. So I really hope up to that point, everything is clear. One last thing I want to touch right here is going to be, so at this point, you want to talk about closures. What are closures? Now, if you're coming from a JavaScript background, I'm quite sure you've come across the word callback functions, okay? Callback functions are basically functions that you can pass as a parameter to other functions. Then you execute them somewhere within that function you've passed them in as parameters, okay? So you can basically pass them as variables to, functions, or use them within the function, okay? So how do we declare such functions in Rust? Now in Rust, those are the functions referred to as closures, okay? So we really don't get confused about that. So how do we declare such a function in Rust? That is what we're going to cover lastly, as we call it a session. So let's do a variable. Let's call this variable Let's call it callback. Okay, for lack of better name, let's call it callback. Then our callback variable is going to store a function. It's going to store a function. So we know the declaration of this function is not going to be the same as the other functions, because you realize these other functions have been declared out of function. So you declare them outside function. But a closure is being defined within a function. So apparently we are inside the run function. So we are doing this within the run function. Okay. But these other functions came outside the run function. So that is one thing you need to note. A closure can be defined within other functions. And here is how we define it. So instead of the brackets, so usually in JavaScript, here is what you do, right? That is how it appears in JavaScript. Now in Rust, we do away with this unless you want to specify the return type. Then we replace the two brackets with those two standing symbols. Okay, so with that, then you terminate it with a semicolon, and by that you have your callback function in place already. Okay, callback functions, something else to note, can make use of the variables within the variables local to the function you are declaring it in. So it can easily make use of these, of the variables here within the run function. So like for instance, we have the variable result, right? So we can easily, or the student name. So we can easily make use of these variables within our callback. What happens is it will simply, if let's say we went ahead and if we went ahead and had a print statement, what did I do? A print line statement right here. Okay. Then within this print line statement, we wanted to make use of the student name. So right here we can say from our closure, we are displaying the student name. So we want to do student name right here, right? So what will happen is this function, or during the compilation of this source code, the value for student will be moved to this callback. Okay, so by moving is it is going to make another copy of this value within this function. Okay, and so we are going to have double memory usage if you implement it this way. So again, these are just some of the things you need to be careful with while you're working with closures. You could run into double memory usage if you're not careful. So let's go ahead and see how this prints out in our terminal. Now that we've stored this function within the callback variable, how do we call it? Down here, we're simply going to do callback, then the two brackets, and then we simply terminate it. So by doing this, we should be able to call our closure function. Let's see if that is actually the case. So we expect it to print from closure, then the student name, which in this case is Destiny. So let's do cargo run and see what is going to print. Awesome. So the from closure Destiny, the line I've just highlighted, was printed within our callback function. Okay. The other thing to note with callback functions is that you can as well call it within other functions. I mean, you can pass it as a parameter to other functions. So I'll just create another function out here. I'll just call this callback test. Then I'm going to pass our closure as a parameter to this function. So I'm going to expect a callback. This is going to be of type function. Yes. Then I'm basically now going to, first of all, I'm going to print. Let me first of all print something here. So I'm going to print from callback test. Yes, from callback test we have. Then I'll just call my callback function, right? Sorry, my closure inside there. So right here, I have a callback function, a callback test function, sorry, that is accepting a call. So this is a closure we are going to accept, and it is taking type function. So it's of type function, okay, as specified right here. Our function doesn't accept any parameter. That's why this one is empty. The fn bracket is empty. But if it were accepting any parameter, would specify the data type of that parameter right there. But as it is, very simple, we just accept it as it is. Then the first statement we're going to print is from callback test function. Just add that. Then we invoke the closure we've just passed into this function. Now I'll just go ahead and invoke this right here. I'll just go ahead and invoke our callback test function, then pass our callback as a parameter to that function. Let's see how that is going to work. So this one is telling me there's mismatch type, expected this pointer, but then it found a closure. Okay. If we use a reference there. Oh, okay. Let's do this differently. Let's say we had that. Then right here, come on. The machine is hanging, guys. The machine is tired. Yes, so right there, we have this particular callback inside here. So inside here, we have, let's print from closure, but then let's not make use of that variable. So let's print hello from closure, right? Then inside here, I think I need to do away with that. Great. Yes, so that is now working right here. That is now working. I wonder why it refused the why did it refuse these other one? Callback. I think I'll do research on that, guys. Then I'll come back with a reason why that is raising an error. So I saw a hand up. Destiny. Oh, I think he has just dropped. Okay, can just proceed. So guys, this is how we do this. You realize right here I have a function, the normal function we've been declaring, but then I'm passing in a callback, a closure to it. Then I'm invoking that closure within it. Then when it comes to invoking the callback test, I'm basically passing the closure itself as a parameter right there. So the closure itself. Now, if I try to run this, if I go ahead and run this with our cargo run command, you realize it prints from callback test function, we have hello from closure. Okay, so first of all, it printed, let me get back there, it printed this statement. Then the call or the closure function was invoked. And by invoking that closure function, we passed in hello from closure string to be printed. And that is basically why we have it coming last. So that is when it was executed. Okay, great. So I really hope I never confused anyone. Let me have the callback one put in place right there as well. Yes. So I really hope I never confused anyone. That is it about functions.